10th CBSE Chemistry, Chapter Carbon and its Compounds. In this video, you're going to learn the esterification reaction of ethanol with ethanoic acid and also the saponification reaction with sodium hydroxide. Let's start this video with an activity. Close your eyes and imagine as if you're feeling the fragrance of your favorite flower or fruit. Enjoy the fragrance. Slowly open your eyes. Now, how do you feel after smelling your favorite flower and fruit? Well, you would have felt great. And when you felt the smell of the favorite fruit, your mouth would have started watering, right? Now, have you ever asked yourself a question as to what may be the reason behind these fragrances? The reason is a chemical compound called ester. When you're walking by a fruit stall or by a flower market, the beautiful fragrances you experience is because of the volatile esters which are given out by fruits and flowers. Now let's study about esters in a bit more detail. The term ester was coined by German chemist called Leopold Gmelin in 1848. Now let's have a look at the general structure of this compound. Here it goes. Here there are two functional groups which can be alkyl group, aryl group, or even it can be a hydrogen as well. There are so many different esters in the nature and so many industrially produced. These esters get their name from their parent alcohol and an acid. It simply means that esters are manufactured using alcohol and acid, and whenever an ester is produced, its name is derived from the names of the alcohol and acid from which it is manufactured. Now let's study the manufacturing process of ester, which is also called esterification. So let's write the reaction in the equation form. So here we are using ethanol, the alcohol, for the reaction with ethanoic acid, the carboxylic acid. So it is C2H5OH plus CH3COOH. This is ethanol and this is ethanoic acid. So this is the parent alcohol and this is the parent acid. Now they both react together in the presence of concentrated H2SO4, that is the sulfuric acid. So when the reaction occurs, the resultant products are ethyl ethanoate, which has the molecular formula CH3COOC2H5 plus a water molecule H2O, ethyl ethanoate, or simply ethyl acetate. So ethanol reacts with ethanoic acid on warming in the presence of a few drops of concentrated sulfuric acid, resulting in a sweet smelling ester called ethyl ethanoate. This reaction is called esterification reaction. As you can see, we are using concentrated H2SO4, which again acts as a dehydrating agent which removes all the water which is formed during the reaction. So this reaction, in which a carboxylic acid combines with an alcohol to form an ester, is called esterification reaction. Now that we have understood how the esters are produced industrially, let's move on to the application of esters, how it is used. Esters are used as artificial fruit essence. You could have remembered when you drink artificially flavored fruit juices, which gives you the taste of apple or banana or a lime juice. The artificial fruit flavor is because of the artificial esters which are used in them. So pest and insect control chemicals are also produced using the esters. Pests and insects are known to give out the pheromones, which are chemical signals. So these pest control chemicals resemble the pheromones, which in turn act as a chemical signals or messages. Esters are also used in fragrance and perfume industry profoundly. These are some of the commercial and popular uses of esters. Esters are chemically the carboxylic acid derivatives which are formed by the reaction of a carboxylic acid with an alcohol. Let's move on to the next reaction of ethanol, that is saponification. Recall the esterification reaction. It was the reaction of alcohol with a carboxylic acid in the presence of concentrated sulfuric acid to produce an ester and water molecule. This reaction is a reversible reaction. On treating with sodium hydroxide, which is an alkali, the ester which is produced can be converted back to alcohol and the sodium salt of carboxylic acid. Now let's see how it happens. And this reaction is called saponification reaction as it is used in the preparation of soap. So let's write the equation now. So the ester produced was ethyl acetate, its molecular formula being CH3COO C2H5, which reacts in the presence of a base which is sodium hydroxide, and the resultant products are CH3COO Na plus C2H5OH. You can see this is the alcohol, ethyl alcohol, which is obtained back, and this is sodium salt of ester. Now you can see that in the presence of a base, we get the sodium salt of the ester along with the alcohol which was used initially. This reaction is known as saponification reaction as it is used in the preparation of soap. So let's define the reaction. A reaction in which an ester is hydrolyzed by a base to give an alcohol and the salt of acid is called saponification. So we understood the two important reactions which ethyl alcohol or ethanol undergoes. The first was esterification reaction which produced the esters, and the second was saponification reaction. Let's have a quick recap. The reaction in which a carboxylic acid combines with an ethanol to form an ester is called esterification reaction. We also understood that the esters are produced industrially and they are used for a number of purposes, like in pest control, they are used in the preparation of or the manufacture of perfumes. Also, they are used as artificial sweet essence. Moving on, the second important reaction was the saponification reaction in which an ester is hydrolyzed by a base like sodium hydroxide to give an alcohol and a salt of acid. This reaction is used in the preparation of soap and hence the name saponification. In this video, you understood two important chemical reactions of ethanol, esterification and saponification.